Okay, this is an unboxing of the Yeti SmartBench stylus kit for being able to have a weight stylus that will be able to work with different tabletops. They won't have to be exactly plumb with the machine because it's a sliding weight-bearing bit or mechanism that's going to hold the pens or hold cutters. So these are the different styluses, or collets that come with it. A ton of different sizes. You can see 14, 15, 16, 11, 12, 13, 8, 9, 10, 5, 6, 7. So it's 2, 3, 4 through, so it's 2 through 16 every millimeter. These are the standard Sharpies. These are the ones that they have in the UK, but they're the same ones we have here in the US for the US market. And this we'll look at in a second. Of course, it's very adequately packed. This is beefy. So the idea with this is that it will be able to float up and down with the weight of everything. So even if your surface is not perfectly flat, it will be able to modulate with it, which is a problem I had, because I had tried the Donex system as a cutter for cutting large oversized vinyl sheets, and it just didn't work as well as I had hoped. I gave some feedback to them, and this will eliminate the problems I had. If I had surfaced my table all the way through, then it would have worked fine. But I hadn't, and the way a lot of the shops that I work with, their needs are they'll be doing one project then another, and they don't necessarily have time to swap out and go with a full setup of a surfaced tabletop. I mean, they can if they have to, but this will eliminate that. Just throw a fresh flat sheet down that doesn't have a bunch of cuts in it, and you should be good to go. So we'll keep opening this up and see what we have. And then inside the padded bag, we had this will hold the cutters. That's a spring-loaded stylus. Then there's a 30, 45, and 60-degree cutter that will be inside of here, and they will that'll keep it pressure-loaded for being able to ride up over inconsistencies in the material. So that's a great-looking kit. Can't wait to try it. Okay, so with this kit, I'm going to clean all this up a little bit. So I'm going to build a little working tray for this, so I can keep all of the collets, the cutters, and just a pocket for these, because I'll have other ones as well, other types of writing instruments probably that I'll play with. This and this all needs to be kind of in one place. So I'm just going to take a piece of melamine and cut a little pocket so I can drop these in at the appropriate sizes. Again, this is 2 through 16 in collet sizes. So what I would do first, I want these to just drop in clean, and then the base will stay. So I'll just cut a square that this will drop in fairly deep. So if you go to pull this out, you can lift the whole thing out. You just dump the collet out once the plastic's off it, and then this goes right back in the spot. The collets are just the standard, look like router collets, but all kinds of different sizes with a 25 nut. So it's ER25 setup for the nut. So I think that's what I'll do, but for now I'll be able to put them in with the covers on them until I figure out which are the sizes that I use the most. So basically I'm going to draw a series of boxes of squares, set them up as an array in V-carve, and then cut them. I'm going to cut them a little undersized and then keep sneaking up on the final dimension that I want. So what I'll do is I'll throw the calipers on them, on the bottom of it. That's a 1.184, sorry. And I had zeroed it out ahead of this. It's hard to do with one hand. Okay, so it's zeroed out. And that's with me squeezing it harder. If it's just going up to the pressure, it's going to vary depending where it's grabbing because the plastic's a little deformed. So 1.18 and then change. So it may be another 9 thousandths or 10 thousandths that I want to do. So I'm going to do that as 1.18 as the size of my hole. And I'll go 3/8 deep, half the thickness of the 19 millimeter or 3/4 inch material. I'm just going to do this as a quickie. And then see how I like that. And then keep sneaking up with a cutting allowance and not changing my geometry or my vectors, just changing how the tool is being set to the inside of those vectors. I'm going to tell it to sneak out a little bit past it, until I have this where I like it to drop in and out. So it's really pretty simple to do. Okay, just as a side note, the 6 millimeter collet will definitely fit the 1/4 inch Donic. So this is the Donic setup. It's bigger, it's heavier duty. You can put the tool down differently. It's also got a rolling and compressing wheel. And I think Yeti's going to come out with a pressing wheel as also to be able to crease the cardboard. But this is a nice kit. Had it for a while, and so it will work in the 6 millimeter collet. Of course, 1/4 inch is 614 or whatever the decimal equivalent of it is. But so it's all good. So the question is, will I end up keeping them in the little boxes, or will I just want to cut them and do I could use a tapered bit to cut it, and it would have a shoulder that drops, or just do a circular cutout. So there's different ways. They're not marked. The collets don't seem to be marked, but they are oily, so I can't really mark them with a Sharpie yet. I can clean them up, but then they don't compress if they're not oiled properly inside the nut. So they do, in this case, this was a 6.1 and change if I did the calipers on the inside of the hole. So they'll be easy enough to figure out the sizes if I have, for some reason, I take a whole bunch of them out, or I drop the tray and they all roll out and I need to get them right. They're 1 millimeter increments, so they're all good. That's kind of neat. We'll just see how this goes. Okay, so here on the machine, I had a spoil board that I had screwed through into the table of the SmartBench. So I just took my pre-finished birch and screwed it in with 1 screw here and 2 over here behind the X-beam. So put it on fast and move it. So I have 2 screws here. So I'm going to set my origin point is right here, and I've got a 1/2 inch or so. I mean, I took the drawing and offset it a bit. So I'm just going to move over to that area. I'm going to drop the Z down. I've got the 1/8 inch tool already chucked up. I'll put it on slow and then move over till I see the screw hole. That's the screw hole right there, so I'll go over just a bit and I'll set that as my origin point. It's going to ask me, is that where I want my datum, XY datum, and it is. The next step would be to touch off the tool. So I'm going to move the bit in a little bit and move it over, and then I'm going to take our touch off tool, put it under there, and I'm going to hit Z0 here and then reach the tool just to hold it down with my finger. The Z's going down very slowly. It touches off. I get a green light and it goes back up. By the way, all the dust I was cutting with a track saw. So it has touched off. We know where the corner of the part is for our drawing to be oriented. We know where the length of the tool is. I can go ahead and just load that job. I think I've already done it. Yeah, so I'll back up a little bit. So I'm going to go to the razor job. It was a razor cutter plate, and the first tool, that's why I number them 1, 2. So the first tool I'm going to use is this, and if I look at it, that's the first tool is for pocketing text, and it was a .125 end mill. That's what I've got in there. I'm ready to go. Tell it OK. It loads it. I don't have to check it. I never check anything because I'm using VCarve. I know the post is right. If the drawing's good and I toolpathed it properly, it's good. So it starts to show me what it's got, and it's going to run the text there.
It's going to be hard to show, but it's showing the text running this way, which is correct, and I'll tell it to go. Now I want to make sure I have my dust collector ready. So this is the 4-inch dust collector that I have a different video on. And I don't usually do this with one hand. I guess I can. I'll adjust that later and make it tighter. But that'll work. The dust collector's on. I've got it going through an overhead 4-inch PVC. This is a 4 to 3-inch conversion with a 90-degree elbow. And that's it. That's all I have to do. And that'll do a great job. I'll tell it to run the job. The dust control is already on. Risk of fire, never leave it unattended. This is an update that I just got today. So I tell it to go. I've got it programmed at 40 inches per minute with an 1/8 inch bit, so that should be fine. But I'm here and I can slow it down or I can speed up the spindle. I have the SC1 1 kilowatt spindle in. It goes to the origin point. Whoop, I'm going to stop it. It's raising up. What I saw was when I put the tool in, I didn't tighten it. So I'm going to do that real quick. Do I want to pause the job? I'm going to just leave it there. I'm going to tighten it real quick. I can't do that with one hand, so I'm going to pause it. Okay, so what I had done, I put the hex tool in, tightened it, so now this does not rotate. That was improper. So I may resume or cancel the job. I'm reading the console. I'm going to resume the job. And it's lowering it to the safe height that's set in the software, which is, I think I have 1/4 inch or 0.2 above the material. Spindle's on, and it's going in, and it's cutting. It does not sound like it's hurting it at all. There's no overload on the spindle, and it's going to carve away. So I'll let that finish, and then I'll change the bit out and hog it out. If I have, then I'll insert my parts and see if the little parts for the different collets all fit in the squares that I'm cutting properly. If they don't, I'll come back in on the profile lines and do an allowance and overcut them to make them a little bigger. I don't need to redraw it. I don't need to do anything like that. I can just do a different profile pass with the same tool in there. So that'll work fine. Okay, as is often the case, the plywood, because of the layers, it didn't do a nice job with the engraving of the text. So I'm going to cut a little deeper and get into the next layer. I'll show you what it looks like. Okay, so you can see that some of this, just the layers broke out and got sucked away. So I'm going to go a little deeper. I think I was an 1/8. I'll go another 1/16 and just see what it does. And if I have to run it on run it again, I'll let it go again. And I could fill this with resin and then surface it off, but this is already pre-finished, so I don't want to get into that. It's more work than I want to do. This is just a work tray. Okay, it had been set to a 1/16, so I just did another 1/16 for a total of an 1/8. So I'm going to just reload the job, and it's already cut a 1/16 out, so the next 1/16 is going to go right on top, right underneath it. I didn't change anything. I did make sure I had refreshed the job, and that's the new one. And one thing we'll show here, I may need to set a new Z because it's expecting me to have a different tool in there, but I'm not. I have the same tool. So that's good for the warning, just in case I forgot. And we'll cut it again, and we'll look at the profile lines. This is cut in the same spot. So this is starting again from the home position, going back out. So the repeatability is something people often ask about because this is a different type of system. But the gantry is connected to the base. If the whole base is, if I'm moving this quickly and it's rocking and rolling, it does move. It racks a little bit, but it moves together. And that's what is so different from other machines. This is set up with engineering allowances in it to move. We're not trying to make a 10,000 pound machine, but we need riggers to move into the shop. The question is the work repeatable? And it is. So we'll look at that in just a moment. Okay, that looks better. It's not all broken out, just based on the layers. So that's good. I'm going to let that go. I'm going to do a tool change. I just showed you how to do a tool change, but they're in plenty of videos. And I'm going to probably break down a bunch of different individual operations on the SmartBench so that folks can look at, you know, how do I do it, change a tool, and just see that rather than see a whole operation of a whole job. But it just takes time, and I'm short on time. So I'm going to put the 1/4 inch bit in, and I'll do the pocketing, and we'll keep moving on. Okay, so I loaded the second job, which is the second tool. It's pockets and border cutout. I've got tabs on it so it won't move, and it started showing me the preview, and I can zoom in on this. It doesn't have enough graphics memory to do the entire pocket, because there's more of these squares and things like that, but that gives me an idea of what I'm doing. So I'm good there, and I'm going to tell it to start. This is programmed at 100 inches per minute. If the job pauses, you want it to lift automatically, but we do. I've already touched off the tool. We've already set the XY datum when we first started the job, so I don't have to do anything with that. I just tell it to go. And so it's going to take a second. And the Z is coming down. Goes to the save spot. It'll move to home and then move out. 100 inches per minute with a down spiral 1/4 inch. I don't even recall how many passes I was doing. So it's finished the ramp in. And now it's cutting. Again, it's under no load. That's good. I could speed it up. I'm just going to let it work. While it was doing the engraving, I was cutting some trim on my track saw. So got to take some trim home. We're remodeling, and got to run some of that. So just let this do the pockets. Again, while I'm doing other work in the shop. That's what a CNC should do. It should work for you. Okay, so it's doing the pockets with a 1/4 inch down spiral, and I did it in, I'm not even sure how I programmed it, because I had done the drawing last night. But it's just stupid slow. So I know I programmed it at 100 inches per minute, so I'm going to jack the speed up significantly. So I'm 150% of the 100 inches per minute. Much better clip. I could have been more aggressive on the number of passes and step downs that I was doing as well. So this is 3 passes. So I was doing an 1/8 of an inch step down with a 1/4 inch bit. That's okay, but I could be much more aggressive. And I still may have to do a 1/16 of an inch or so, depending on what layer it is of the ply. If we look at the plywood down there, I could be in a glue line, I could be in an area that just doesn't look good, so I may want to drop it down after this runs another 1/16 or 32nd or whatever. I'm going to jack it on up, so I'm at 175% speed of the 100 inches per minute. I'm just going to go to 200. That's the maximum we can change it on the machine. So I programmed it at 100 inches per minute, but I'm telling you to go 200% of that. So it's doing the ramp in, and then this is the full cutting speed. And that's the full depth of cut for the passes that I had programmed. Now it's doing the step over, so it's only exposing a certain percentage of the bit. So this is fine. I'm just going to let it run. I've got other things to do. And again, this could be done in 1 pass, really. If I went slow, or 2 passes would be better. But I've got it programmed at 3. Doesn't matter. Just let it work. Okay, here it is after it's finished. It was cutting 100 inches per minute. I accelerated it here on the console to 200 times that value. The faster we cut, the more debris is going to be left. This I haven't done anything with. This is the way it was left. So after all this pocketing, that's all the debris that was there. Using the 4-inch dust collector, I've got 650 CFM, but I'm coming, probably 30 feet between pipe and then the flex hose and this setup. That's a different video. 4-inch dust collector. These are the collets. They fit right in. Kind of snug, but good, because then I can see all the collet numbers, names and numbers. Pull them out, pull the collet out, do the work, put it back. So I'm not even going to change those at all. These were for the 30, 60, 90 cutters. And then these pockets, circles, were for this. And they're a little tight. It goes down, but I have to push it. So I'd like to make them a little bigger. going to make them a 1/16 bigger. Just going to use the profile line that I used to create this. Just tell it to cut on the inside of that line. And then I can do a tool allowance to adjust for it to overcut that. So that's all that I'm going to change is this, the same depth of cut, but just a little bigger, a little bigger, a little bigger, 1/16 total. And this will drop right in and stay sitting and balanced. I didn't check the Donix box here, but I will. And I'll make those adjustments. I've said this before. If you're not getting good chip load, you're cutting wrong. You're cutting too slow or have your RPMs too high. This is the minimal chip load that I have, and these are like grains of sand. I don't know how it's focusing well or not. But I like more chip, higher chip load. It cools the bit better and does a better job on keeping your tool sharp. So you get better chip load by either slowing down the RPMs or speeding up the inches per minute through the material. But that's awful slow, so I'm going to jack it up speed-wise. So now it's doing the tabs. I don't know if we'll have enough space for it to see the difference in chip load, but I brought it up to 195% of the program speed. And it slows down at the tabs because those are used at the plunge rate. So it slows things down to whatever you have programmed in that. So I could have jacked that up if I wanted to in the programming, but I left it fairly slow. And now I could have it doing a reverse cut and coming in 10 thousandths to do a finishing cut. So you want to see the witness lines of multiple depths, multiple cutting steps on the side of the material. I'm going to edge band this anyway, I think I have some, but if I don't, that's okay. I'll just sand it on the edge sander and off we go. So that's the finished product. I'll grab the shop vac, or actually this will work just by undoing this, and that'll take it all the way out. Okay, I'm not sure if that was recording or not, so I'm going to do it again. I just took the dust collector and went around everything to pick up all the debris that I could. I can see the tabs. I can see I've cut all the way through into my MDF spoil board just by looking through here. So the more I pick up this way, the less I have to clean up off the floor or off the table before I run the next job. So if I had bristles and stuff on this or a brush, I could pick that up too, but this is just letting it pick up just based on the air volume. So it works well. Okay, I just cut the tabs off with the oscillating tool. And here we are. Nice looking little project, no sanding. Again, this is just storage space. Played with the depth here so I could get to the right layer because of this is a limited, this isn't a real thick. And you can see it's all glued up inside it. But that's okay. This is just a storage piece. And I can clean this up with a wire brush. I keep little tiny wire brushes to go in here and just take the fuzzies out. But that'll work well. And the way I'm going to use this, I have a lot of these upright filing cabinets, and I'm going to build a short box in height. Take these out, and I'll have this just sitting on top of it, so I can have it here. I can slide it out of the way, get what I want, lift it out, whatever I need, and ideally I'll set up multiples of these at different layers so I can mix and match and slide them over each other. But this one I know what I'm going to have mostly in this particular cabinet, but I have a bunch of these cabinets across the shop. So yes, if you're watching and you have a kit, I did one too few storage holes. Probably had one out when I was playing with it when I first unpacked it, counted them, and one of them wasn't with the set. So redesign, make it smaller. I still need it to be this height so that I can put it on the shelf and slide things around and have multiple layers of storage. But I don't need it this big. I can have the Donix separate, and I can really cut my size down. But let's put at least the proper number of storage parts. But this works good. They're labeled. Just pop them up, pop them out. I haven't even opened and unbagged some of them, but pretty simple. I'm going to put a hook here so that I can get into some of these smaller ones. So once the plastic's gone, I'll be able to grab them with a hook or pull it out. It's pretty simple. It's a nice snug fit, so that works well. That's the 3, 10. Again, I could engrave that into the panel as well. Simple storage. See how I use it. Throw extra pens on it. You know, it's just a simple storage tray. Works well. Thanks for watching. I sell the Yeti SmartBench in the United States and helps train my customers, get them up and running. Got a lot of experience on this. I introduced the SmartBench to the U.S. market and love to help you in any way I can.